So let's start with the first 5. How about 1 through 5? Any of those we want to look at together? Okay. 1. And 1, we got an integral from 0 to 1. We got square root of x squared plus 1. And ultimately, you just got to recognize that it's a power function. So if I distributed the radical x, I'd have x to the 1/2 times x to the 2. So it should be x to the 5/2 plus x to the 3/2. X times x, add the powers, and if we do if we add 1 to that, it'd be x to the 7/2 over 7/2, and x to the 5/2 over 5/2 on 0 to 1. And if we put a 1 in there, we're going to get 2/7, 2/5. And ultimately, if we add those together, we get 35ths, 14 35ths. Nope, 10 35ths, sorry. 7 times 5, 2 times 5, 14, 24 35ths. Something's not right. What did I do wrong here?
X to the 1/2.
There we go. Oh, just 1/2, sorry. Nice. So that'd be just 2 there, right then. Okay, so 2/7, and then this would just be a 2, so that'd be 14/7. Nope, 14. Try that again. So the x to the antiderivative would be x to the 3/2 over 3. There we go. So ultimately we get 2/3 here. So it would actually be 21st. So we get 6 21st, and then over here it would be 14 21st, it would be 20 21st. How's that match up? That good? Yep. Alright, so ultimately again, x to the 1/2 makes x to the 3/2 over 3/2, so 20 over 21. Alright, so again, looks like a fairly complicated integral when we started, but ultimately, again, it's just a power function, so if it's not obvious what the antiderivative is, one of our options is to manipulate the integrand, do some algebra, do some trigonometry, whatever it takes to get it in a form that will be useful. And again, if it's on a non-calculator part, it's not going to be anything that we can't do. So think about all your different options that you have in terms of integrating and so on. What else? 1 through 5. Okay. Number 3, we have the function is x to the 4th minus x squared. Has a relative minimum at. Well, relative minimum would occur when we have f prime, which would be 4x cubed minus 2x, when that equals 0. If we take a 2x out, we'll be left with x squared minus 1. So that means our points in question would be 0, -1, and +1. So if we do our first derivative test, and we go with our actually, oh, is it?
Like when you were factoring it, it's 2 and 2. It's 2 squared 3/4.
Ah, gotcha. Thank you. So let's try that again. So these would actually be halves, square roots, right? So plus and minus. So we'd add 1 divided by 2 would be square root of 1/2. So it would be square root of 2 over 2. So 2x squared minus 1. We'd have 2x squared 1. So x squared equal 1/2. So if we square root both, we'd have 1 over square root of 2. Which would be square root of 2 over 2. Alright, so now that we did that, let's go ahead and do our testing. if we test something less than this, like say -3 for instance, we'd have a negative here, we'd have a positive here, so that would be negative. Like -1 in there would give me negative, and give me say negative radical 2 over 2 is actually negative, it's actually 0.7 something, so we'd have to go like -0.5, if you will, -0.5. So -0.5, let's say, would be negative here. -0.5 in here would make -1/4, which ultimately would make this to be less than 1. So it would be negative times negative would be positive. If I put a quarter in there, or a half in there again, I get positive here, negative there, would be negative here. And then anything beyond that, like 3 for instance, again, would be positive here, positive. And again, we're looking for where do we have a relative minimum. So it looks like we could have relative minimums at both here and here. But the only one that's an option is the C. Alright. Questions on number 3. Others, 1 through 5? Evan?
4.
And number 4, we have derivative function, or derivative of just x squared e to the ln x cubed. Alright, so if we want to find the derivative of x squared times e to the ln x cubed, I would start by suggesting that you simplify the integrand to x to the 5th before you do anything else. This is what happens here when we have e to the ln of x cubed. E to the ln of x cubed is just x cubed, isn't it? So really we have x squared times x cubed, which is x to the 5th. So therefore the derivative then would be 5x to the 4th.
Alright.
That would do it. Anything else 1 through 5? Okay. 2, we get x equals e to the 4t. And y equals sine 6t. And we want to know what is dy dx. So when we have a parametrically defined function, we need to remember that dy dx is going to be equal to dy dt divided by dx dt. So if we know that, then our dy dt here is going to be 6 cosine 6t. Derivative of sine of 6t would be cosine 6t times 6. And then e to the 4t is going to be 4 e to the 4t. Alright. And ultimately, with that, we would have question is which one of those is the right one. Looks like our choices are yeah, I guess it would be A. They just took the e to the 4t and put it on top. If we got e to the 4t on the bottom, we can put it on the top and make it e to the negative 4t. So the 6 and 4, of course, are going to be your 3 and 2. They just brought the e to the 4t up top. So remember, trust your calculus if you had this part. Try to see if you can do some algebra and put it into the right form to find one of the choices. Because all they do is just take that, put it as a negative power up on top. Should be choice A. What else? 6 or 10? On 6, we have says we have curve negative x plus 4 square root, and it says find the slope of the line that is normal to that curve at the point where x equals 0. So remember, normal lines and tangent lines are perpendicular to each other. So if we find y prime here, and we rewrite this as negative x plus 4 to the 1 half. Write it as power function. We get negative 1 half x plus 4 to the negative 1 half. Right. And ultimately, if we want to know the slope at 0 here, so y prime at 0, it's going to be negative 1 half times 4 in here to the negative 1 half. 4 to the negative 1 half is going to be 1 over 4 to the positive half. So in other words, 1 over the square root of 2, or square root of 4 that is, would be a half. So it'll be negative 1/4 altogether. So again, you got negative 1 half. This is going to be 1 over 4 to the 1 half. Or 4 to the 1 half is just 2. So it'll be a negative half times positive half, be negative 1/4. And ultimately with that, that is going to be our slope of our tangent line at 0. Slope of the normal line then becomes what? Opposite reciprocal would be 4. The letter choice C. What else? Plus? Okay, in 10 we have 0.52 is on the graph of this y equals h of x. And it says find an equation of the line tangent to h of x at 5, 2. And I think we're looking at that top graph above, aren't we? Yeah. Okay. So we have this h, it's continuous and differentiable on the domain 0 to 7. The graph of the derivative is shown, keep in mind. And so ultimately, it says the 0.52 is on the graph of h. We're looking at the graph of the derivative here, not the graph of h. And we want an equation for the line that's tangent to h at 5, 2. Well, ultimately, my point slope form would be as such. And we can see the derivative at 5 is 1. And remember, here's where we have to be careful. We're looking at the picture of the derivative. The y values of that are the derivative of h. So that means we'd have 1 there. And I don't know what form it's in, but actually it's in that form, isn't it? It'd be choice A. What else? Okay. On 8, we have 1 to infinity of x squared, and then 1 plus x cubed, all squared, dx. We're going to do that improper integral. BC problem, we'll go limit as b approaches infinity. Go from 1 to b, x squared, 1 plus x cubed, all squared, dx. Pretty typical substitution problem because the 1 plus x cubed derivative is related to the other stuff that we have there. So if we do our u substitution on that, we can get rid of x squared dx by replacing it with 1/3 du. So in our integral we'd have a third out in front. We'd have 1 over u squared du here. Where the x squared dx is going to be replaced by 1/3 du. The stuff inside the parentheses is u, so we got 1 over u squared. If we do the antiderivative of u to the negative 2, it'd be u to the negative 1 over negative 1. And we're going from blank to blank. I'm going to take it over here and finish it. Ultimately, we'd have 1/3. We'd have negative 1 over u in the brackets. And I'm going to replace the u now. So what is it, 1 plus x cubed? Put that there. We're going from b to 1. Alright, so ultimately if I put a b in there, what's going to happen? If I let this bottom get infinitely big, that's actually going to be what? If I put infinity in here, it's going to be 1 over infinity, isn't it? Which is 0. And then minus. In here it would be negative. And I'd put a 1 in there, I'm going to get half. Negative 1 half. And so ultimately I'd get 1/3 times positive 1 half, which would be 1/6. Hopefully that matches up with something. The letter D. Questions on that one? What else? 6 through 10. I had marked down that I had some trouble with 7 to do it. We got 7 right?
Figured it out now, but I didn't get it right first. Do that.
I want to see. Ultimately, it's implicit differentiation. So, what do we have to recognize here on this first part? Product. So let's see if we can come up with something here. If we do the first times the derivative of the second, derivative of y squared, of course, is 2y dy dx. And then if we do this one, we'd have 3 over y dy dx. 3, of course, is constant. The ln y is just 1 over y times the derivative of y. And then on this side, we'd have a 2x. On this side, we have a negative 6y dy dx. So far, so good. Alright, if we collect our terms on this side, we have 4xy dy dx plus 3 over y dy dx plus 6y dy dx. Over here, we'd have just 2x only.
Supposed to be 3y to the third.
Where am I? Oh, did I write the problem down wrong? Oh, this is 3 cubed. There we go. Alright, so that's actually a 9y squared then. So 9y squared there. That would help to write the problem down, right? So 9y squared. Everything else look good so far?
Yeah. Wait. I forgot when you did the product rule, you didn't do the y squared times
Oh,
2.
yeah, duh. Nice. Okay, so first times the derivative of the second plus the second would be y squared times 2. And ultimately that would end up with a, at this stage we'd have a negative 2y squared over here then. So we would, that doesn't have a dy dx with it, so we had to move that over to the other side. Alright, so wake up. I think we're good now. Anybody see anything else that we missed? So we got first times the derivative of the second, second times the derivative of the first. Alright, within our dy dx then, we get everything straight here, 2x minus 2y squared all over 4xy plus 3 over y plus 9y squared. Should be the right derivative. And the point here is what, 3, 1? Alright, let's see if that works out then. We'd have a 6 here minus 2 here on top, putting a 3 here and a 1 here. On the bottom we'd have 12 plus 3 plus 9. 4 times 3 times 1, 3 over 1, 9 times 1. So we'd have 4 on top, and then on the bottom we'd have 24, 1/6, which corresponds to E. Hopefully that's correct. Good. Alright. So, in the scheme of things, just to simply an implicit differentiation problem, just got to be careful that you don't miss any of the parts, right? You do that product rule part. Other than that, product rule part's probably the part that most people mess up when they do it, I would guess. Anything else? 6 to 10. (11 to 14). Ready?
12.
Okay, and 12 we have 8 25ths minus 24, 1 25ths plus 72, 72. 6 25ths minus 2 16, 31 25ths. And then from there it says the sum of this infinite geometric series is blank. Ultimately we know that it's a over 1 minus r. Okay. And our a is 8 25ths. 1 minus, what is the common ratio here? We're multiplying this top by 3 each time and the bottom by 5 each time. So that R value would be 3/5. So ultimately we'd have 8/25 over 2/5. 8/25 times 5 halves. 4/5. Which correspond to 0.8. Where am I missing something? That's 5, 4.
The
I think
R
it's
and
negative.
Oh, it's negative. So that's plus then, right? So that'd actually be a 8/5 there. So that'd be 8/25 times 5/8. So actually those 8s would go, we get 1/5 as our answer. Sorry. So 0.2. Yeah, the alternating makes the R value negative, not positive. So it should be 0.2, which would correspond with A. What else? Plus? Okay, on 13 we have a particle that's moving. So the acceleration is given. We got A of t is equal to 2t minus 3. Initial velocity is negative 4. At what times is the particle furthest to the left? Alright. So keep in mind we're doing time frame here is 0 to 5. I could write the velocity equation here by doing t squared minus 3t plus c, knowing that the initial velocity is negative 4. That would give me 0 here and 0 here, which means negative 4 would be our c. So our v of t function then is t squared minus 3t minus 4. That would be our v of t function, right? All right, and so ultimately our issue is with this velocity function. If this is our velocity function on that time interval, okay, when is the particle furthest to the left? So we're ultimately asking for position here. Okay. And so if we know that we can find the position, of course. If we, I guess one thing that we could do is just go ahead and find it. So we'd get t cubed over 3 minus 3t squared over 2 minus 4t plus c. And it doesn't tell us what the initial position is here, right? Okay. But we can consider the initial position to just be 0 if we want to. So if we did x of t is equal to just t cubed over 3 minus 3t squared over 2 minus 4t. Okay. We'll give that as our position equation. And that means our position at, we know our position at 0 is 0 if we just consider that 0, 0 to be our starting position. And then from there, we know that it changes directions when we have the derivative equal to 0. So if we set that equal to 0 and find those two split points, we can see where it's going positive and negative, and then determine which one it's going left. Should wind up at, apparently, at 4 is where it's most left.
Just keep these.
Yeah, go ahead and keep those for now, and then we'll continue that later, and then I'll collect them after we get done going over the other part, second half.